Good morning, good afternoon, good evening. Thank you for joining this session, The Masters Under the Bed, Overengineering the Cloud. In the next 60 minutes, we will see why overengineering is something that we are doing so often at the moment in time when we are thinking about microservices, serverless, and working with cloud. My name is Radu Vunvulea. I'm Group Head of Cloud inside Nava, and I would like to thank you for the team that is behind the Data Platform Summit 2020 for organizing this event and for inviting me to share with you the knowledge, the lesson learned, and the thing that I've seen in the last few years. Who am I? Well, I'm a Microsoft Azure MVP and Microsoft Regional Director. And what is here relevant in this context is the following. My first project on cloud, meaning on Microsoft Azure, was on 2010. So at the end of 2010, we went in production with a commercial project. And starting from then, I was involved in a lot of projects on Microsoft Azure, on AWS also, and a few of them on GCP. And I've seen many times different recurrent mistakes or things that were not done as expected. And starting with more and more architecture patterns and ways of deploying, building solutions, and so on, like we have now serverless and microservices that are very easily to achieve. Nowadays, in comparison with 2014, 2017, when it took a few days to build an environment where you could deploy a container, now inside Azure or inside AWS, in 15 minutes from the portal, from the cloud vendor portal, you can build all the infrastructure that is required or even pay as you go and deploy your containers. And what is more amazing that nowadays you have the ability to have containers that are running inside Azure App Services or Docker images inside Azure Functions. So we ask us many times, okay, which service should I use? How complex the solution should be? And we are forgetting that the customer have a fixed budget or maybe some time pressure, or even if the technology is very trendy and is very nice, we might not have the skills in the team or in the company to be able to deliver in time and in budget. So we need to be very careful exactly what we want to use, how to use them, how complex the solution we want to build. For example, if you just want to have a simple blog post engine and you want it to do it from scratch, maybe you don't need complex service broker messages or any other things like that, or even you might not need microservices. You might just need a simple web application and maybe a NoSQL solution like Cosmos DB or some storage to store the content of the post and some comments handling solution that you could build by yourself or use a third party, nothing more than that. So what is our plan for today? I would like to cover three main topics. Why we are doing over-engineering, what we don't take into account, and what we need to be aware. Because the monster called over-engineering, it's all the time under our bed. It's so easily to do over-engineering. And now with the high number of cloud services available and how easily you can integrate them, put them inside CI/CD pipeline and things like that, over-engineering, I think that in most of the cases is already done because we assume, well, in 3 years' time, they might reach 10,000 users. Yes, they might, but we are forgetting that the life cycle of that application might be only 2 years. So it means that in 2 years' time, they will already start to work on another version of the solution where they might include the scaling capacity and things like that. It's not about not thinking about the future, but deciding what is the breaking point. which is the breaking point where you decide that we should stop here. We don't go over this line to do the solution more complex than this. So, statistically, what are the most common causes of a project failure? Well, in 10 to 8% of the cases, inaccurate cost estimation and inaccurate time estimation, 25% of the cases, is one of the main causes. And especially if we take this into account and put over-engineering side by side, if you don't have enough time, maybe you like to keep things simple or as basic as possible to deliver the business value that the customer wants in the given time span. Secondly, cost optimization is the primary reason for 47 of enterprise cloud migrations. What does this mean? At the moment in time when a company is looking to migrate their solutions to Azure or to AWS or to GCP, they don't do the migration just because this is the trend. No, they are looking to do cost optimization to reduce their cost. And when we are saying cost, don't think only about running cost. Running cost is only one component of this. So yes, running cost might generate some cost at the end of the year, but beside this, you have management and operation, you have support, you have cost of that are generated by the internet, by the hardware, things like that, and even including new services or new softwares that are more easily can be accessible from a platform as a service or software as a service vendor versus deciding to run by yourself, managing them by yourself, and so on. So there are a lot of things that are including cost optimization, and we need to take this into account when we decide what level of complexity, what kind of services we want to use to provide the business value to our customers. The third thing is 60% of cloud-based solutions are over-engineering with at least 30%. What it means? Let's assume that we are two people at the table, me and you, the listener. Think about it, there is one of us at this moment in time, if he's working in only one project, is already doing over-engineering with at least 30%. What does mean 30%? Might mean that you use a message broker solution that is too complex. Might mean that it could also be that you decided to use microservices when you could just take a web app and deploy the front end there. It might mean that you decided to use serverless just because you want to use it, not because it's adding an extra value. For example, you have an application, a very simple application, where the load during the month or during the week, if we have week here, and here his load in percent from 100 to 100%, let's say, it's usually the same all the time with not too many variants. In this situation, a serverless solution might not be the best one. You might want to look at the containerization solution where you would already pre-book and reserve instances and resources because you have the same load all the time. And in the future, if you realize, okay, sometimes you could have some spikes, okay, let's see how we can handle them. And for example, in Azure, if you are using containers, you have already mechanism where you can push the overload of your Kubernetes cluster to a platform as a service like Azure Container Instances that would take the load, the load that cannot be handled by your current system, plus other solutions like serverless and so on. So what is my mission? What is my mission for the next 50 minutes is to make us to think outside the box. Let's try to think about solutions that are outside the classical box. If in 2020 everybody is using microservices, serverless, let's say Kafka and complex message broker solution, let's think outside the box. Let's don't think from default that we need this kind of services and many more. Let's analyze if we really need them, or they're already on the market, some other solutions that are more simple or more practical and more easy to use for our needs, and let's try to take them into account. It's not only about technology trends. We also need to bring the real business value that our customer require us. Have you ever done over-engineering? This is a rhetorical question. Ask yourself, have I ever used something too complex or something that in reality there was not a high business impact on the quality attributes or on the value that I brought to the customer? I would say that most of us, or at least personally, I've done over-engineering. And usually you realize that you've done over-engineering once you go in production and you realize, oh man, that solution is so complex. And I realize that I really don't use the service or the solution at the level that I expected. Oops, I just invested 50 man days and take 10K for something that nobody uses. So I could use just a simple queue. I shouldn't use service bus queues for that. This is something that I found on Stack Overflow from Oscar, or a user called Oscar. You have on the bottom right of the slide the resource, and I really liked these pictures because it's capturing the reality. In an ideal world, you would have balanced engineers. And what does this mean? It means that you have a very good balance between hardware, engineering, design, and users. This would be the perfect solution. Reality is very different. Why? Because you have so-called engineers that are kept drilling, and they know that they do bad engineering. They are trying to do also the design. They're trying to cover and to influence things, taking into account the things that they read or new trend and so on. And they are starting to influence and to maybe destroy the initial balance of the architecture and of the solution, influencing the design. The solution, it still works, but you have sometimes the gut feeling that things doesn't look as expected. Initially, we talked about 5 services, and now we have 12, and some of them are in public preview, they're not in GA. And why we are using them? Oh, because somebody read about them. Oh my, that's not good. And also, the third ones, you have the sociopathic engineers. Well, they want to do over-engineering everywhere. They're trying to influence everything, even the user needs, even the business needs. They are trying to change or to change in such a way to be able to push their ideas, their ways of working that in most of the cases are not proved one. They're just things that they read or try to use, or they see that it's a big trend on something and they're just trying to push them in their solution, nothing more than that. Remember, it's not bad to use serverless. It's not bad to use microservices or service bus or Kafka or you name it. No, it's very good to use them, but we need to identify exactly when they are required and how we should use them. This is some numbers of the number of services that each cloud vendor had in end of August, beginning of September 2020. So AWS had around 12 services, Azure had around 263, and GCP around 183 different services. From the computation point of view, there were 13 on AWS, 20 on Azure, and 10 on GCP. For database, 9 on AWS, 13 for Azure, and 5 for GCP. If we include also the serverless and containerization services, we would have in total 17 on AWS, 30 on Azure, and 22 on GCP. This is crazy, at least from my point of view. Why? It's not crazy because they exist. It's crazy at the moment in time when you need to do the architecture, the design, and the implementation. It's very hard to decide exactly from these 30 different computation services, which one should I use? Even for containers, you have multiple services. You need to be very careful which one you decide to use. And this is the hard part, deciding which one is the best for your need, to have a very good balance between features, thinking about the future, customer needs, budget, time, and team skills. Because also the skills of the team are very important. If they never use serverless and Azure functions, and they don't have the basic concepts, hands-on experience, and they decide, let's use serverless, well, this means that the learning curve and the cost of building the solution will be much higher. If you really need that, go with that. But take all these things into account, especially the learning curve that many people are forgetting. Even if you do a very nice architecture where you put all the services, the communication with them, and so on, you will say, this is a perfect solution for us. Even so, if you don't have the right team that is able to build it, you will have issues. So let's take a look on the case study, because usually case studies are the best way how we can understand the problems. And let's start with the story, a very simple story. Let's imagine that we are working on an API that tracks users' activity on their corporate devices. Well, don't think about their keyboard and things like that. No, it's about how long the laptop is open, and maybe things like how often they start their camera or microphone, or because you want to have some insights related, okay, how long they are in calls. Because, for example, Outlook might be fine, even so, they might have some Zoom calls, not only from Teams or on Skype or Citrix and so on. And because of this, Outlook calendar might provide you some good insights, but it might not be enough. And because you want to understand what was the impact of working from home from their perspective, the load on them, things like that. Let's assume that the total number of users is 1,000. The average number of active users, because you're a global company, it's around 300, 600, and you have the average at 300, and the maximum, it's 600 people that peak. Users, all of them are located in UK, and the number of calls per active users, it's around 4 hours would be the average per day, with a maximum of 10. Now, you need to go live in 8 weeks' time. So this means that you have 2 months to understand the business requirement, do the architecture and the design, and also do the implementation. And the budget is for one team. What I mean by one team, let's assume that we have 4 developers, 2 testers, 1 automation person, DevOps, and also we have some support. Half of FTA we have from a front-end user experience person, and half an FTA from a BA. Would be pretty okay. And also we have 1 project manager. Should be fine. This is the understanding on one team. It should be perfect. Now, how you do the design? Well, you start. Okay, we say, okay, we are working on Azure as a cloud vendor. What is the current trend? It's containerization. Okay, let's go with Azure Container Instances. You don't go with Azure Kubernetes Services because it's a little bit too complex. ACH should be more than enough. Oh, we have some other things that are not called so often. Let's try to use Azure Function. That's great. We are putting an API management on top of that. And also we decide to use Azure Traffic Manager or maybe front door. The team decided to use Azure Traffic Manager because they already used, and also the customer never used front door and their security team would not accept front door. Okay, perfect. For storage, well, we are deciding to use Azure Cosmos DB. That's great. It's a very powerful NoSQL storage solution, and also Azure Storage. Perfect. This is the radiography of the core services that you would use, and it sounds very good. On top of that, what we have? We have automation, CI/CD, and infrastructure as code over here. We need to have 5 different environments. We have 8 services in the end that will run as containers. We have 12 different functions. And also we need to take into account auto-scaling, and we need to be very careful because we need to have auto-scaling in place on this part, if it's possible, on Azure Functions, and also something also on Cosmos DB. And yes, beside this, automatically we need services like App Insights, Azure Monitoring, VNet, and everything that is around networking, security, role-based access control, access policies, and many things. So you already have, beside the core of the solution, the core services, a lot of things that you need to take into account. You need to see how you can support them and so on. That's perfect. What is your biggest constraint at this moment in time? It's time. You have 2 months and you have a fixed team. You have one team. And in this 2 months period, even if you would scale up the team and you would add more people, there's a big risk that you wouldn't be able to scale up too much because of the time constraints and the limitation how easy you can scale up with some more people. So you need to go with the current setup. So this is the solution, and we need to ask ourselves about the effort. It is realizable to implement all that we specify in 2 months' time. Could we do this without overtime, without adding more people, without cutting some functionality? It would be pretty hard. And we need also to remember from where we started. An API to track user activity on their corporate devices. All the services that we included here, the main purpose of them is to gather information, to push it to a storage, and nothing more than that. The analyzed part, it's another system, an external system. So we need to go back to reality and to think about, okay, is this feasible? We assume that we will have a team that already have microservices experience. Reality is that we will have a team with no microservices experience, and this might be a big problem. Also, we have 12 different functions. Another problem, we have no hands-on experience in the team with Azure Functions, and that's not okay because we'll struggle. It's not that we will not be able to do that. It's more about the learning curve and the fixed time and budget that we have and could be challenging. The team has very strong experience with PostgreSQL, not with Cosmos DB. Why we wouldn't use not Cosmos DB here? We could use something else. we could use a PostgreSQL solution from Azure, and it would be very suitable for our needs, would work pretty okay, and the team wouldn't need to learn a new storage solution. Besides this, we need to deploy the solution in only one region. So in this case, do we need traffic manager? Do we really need it? Because in the end, we can edit later on in time, at the moment in time when the customer might decide, okay, I want to deploy the solution in multiple regions or maybe in the same region, but to have redundancy, something like that. And we have the biggest constraint, time and budget. And we didn't talk until now about security and infrastructure design. And I've seen, and many times when we do the design, we are forgetting about this part. And security is a time-consuming thing. It's not only the ping pong between the customer and your team, it's also configuring them. Integrate the security configuration with the on-premise ones. Besides this, the design of the infrastructure, it's a trend when we work on cloud to ignore it. Well, we don't need it. Somebody from automation and DevOps could do it. No, it's something else, especially when you need secure environment with very clear segregation infrastructure. It's something else, and you really need to have the right skills for it. So let's simplify the solution. Let's take into account that we have one team of people. We have 2 months time to deliver the solution, and the customer needs that that fixed list of features that were already discussed, and he's not able to cut them off, and he really needs to go in production. So possible solution would be the following: API management for handling and do the versioning of the API, Azure Web App to run the solution, Azure Storage plus Azure Database for PostgreSQL. The team already know PostgreSQL, and running inside Azure Database would be a very similar experience, only the automation DevOps team would have something additional to do. You would start to use Azure Web App, and the good part with Azure Web App is that it's very easy to use, and the team can decide if they commit to build Docker containers and push them inside web apps, or they would decide to go with a classical solution as a web app. And for the CI/CD and automation, we go with Azure DevOps because it's well integrated with all the Azure services. It's easy to use, and there are already existing templates that can be used if you want to build to do the deployment and the default configuration. Other services that we decide to use are Key Vault from the security point of view, VPN Gateway, Security Center, VNet, AD, Policies, Azure Monitor, App Insights. Now, on this side, most of the part will be done by the automation, by the DevOps person, together with somebody from infrastructure and from security. And what I want here to point out that for this kind of team, it is recommended, especially if you have only 2 months time, to think about to have more than one person that is responsible for the automation for the DevOps part. In general, the load on this kind of roles is very high at the beginning, and after that goes down. What would be ideally here would be to have one DevOps person, a good one, that would define the templates, will define the skeleton, and after that, to ensure that the developers from the team are ready to do small changes, updates, enhancements, because in the end, it's not so hard to add some additional things over there. And now we need to ask ourselves, from the effort point of view, the second solution that is more simple. Is suitable to be able to deliver in 2 months' time? How much over-engineering we have now in comparison with the previous one? Are we okay with that? Could we deliver it in 2 months' time? Would be a good match for our customer needs? I think that it is a better match. So, what I would like to ask you to think about this. Think about, I'm doing over-engineering. Ask yourself, is this over-engineering each time when you do a design of a solution? Even if it's not a full design, even if it's just a small system, a subsystem. Think about, I'm doing over-engineering that new service that I want to integrate, or that new pattern or architecture design is something that would bring the extra value to the customer that is looking for, and do I have enough time, resources, and budget to be able to do that? Would be acceptable for the customer to have multiple iterations when the initial version 1.0 is more simple, and in time we adding or we are using other services depending on his needs? What is the life cycle of the solution that I'm building? Sometimes you might build a solution in 2 months' time that will run only for 1 year or 6 months, and after that is thrown away. In this case, it's more important to be time in budget and to respond to the quality attributes that the customer is looking for versus other kind of features. So don't go beyond or above what you really need. We have infrastructure as a service, we have PaaS, we have SaaS, we have containers as a service, we have functions as a service, and many more. And we need to decide exactly on which side where our application would like to land. Somewhere here, somewhere here, somewhere here. And depending on where we decide to put our application and type of services that we will use, it will influence directly the budget, the time, the effort. So on one side, we have IaaS solution like VMs, clusters, containers, and so on. And we're going more on SaaS, like serverless, self-hosted, web host, communication, and so on. At the beginning, things went very slow. We have the VMs, we have the cluster now with container, serverless, self-hosting solution, and so on. Things are going faster and faster, and it's harder and harder to decide exactly what are the services that we want to use, how we want to use them, and so on. Now, let's talk about automation and self-service, because I've seen that sometimes we are doing over-engineering, especially on this side. It's very easy to do that. Why? Because we have now a trend. We need CI/CD pipelines. We need all the time infrastructure as a code fully for any kind of project. Nobody takes into account the time, the budget, and the cost of it. And even for small projects, it's pretty funny to realize that sometimes the cost to implement the full self-service and automation is equivalent to the development and designing of a solution. And if you have solutions that really are pretty small, you need to ask yourself how much automation you need, how much self-service you need. Let's take an example of two projects. One, it's a small project, as we already talked about, an 8 weeks project, where we have one team, 3 developers, 1 tester, half of design lead, technical lead, versus a 1-year project with 20 developers, 5 testers, 4 design lead, multiple environments and things like that. What is the right balance? How much automation you can do in 8-week times versus in 56 weeks time? What is the impact on this? Yes, in both cases, we need infrastructure as a code. Yes, in both cases, we need pipelines. We need automation, we need self-service. But how much we're adding, it will be different. One thing is to have multiple teams, 25, 30 people in a 1-year project versus to have only one team in 8 weeks times and so on. There are things that you need to take into account and to find the right balance. You'll not be able to find the correct answer that can be used for any situation or depending on some complexity metrics and maybe duration, like that, to know exactly how much I need to add. No, you need to feel it and you need to find a balance. It's very hard to do it, but you need to take into account, especially for small projects, how much you want to add. What is the real benefit? And where you need to say stop, it is more than enough. Even if the market trends would say, no, you need full automation, full self-service. Yes, you need, but also at the same time for the customer, going live in the given budget with the given features is very important. And one of the biggest influence from the time and budget is requiring to do automation and self-service is the type of the services, the number of services, and the complexity of them that you are using from different cloud vendors. It's not the same thing if you decide to use Azure Containers instances versus Azure Kubernetes plus Azure Function plus Web App plus Azure VMs. You need to have a full control of the number of services that you are using. Let's take the following example. We have a local file repository that is used to share and save truck insurance purchased by the drivers. It's a very simple solution at this moment in time, what they are doing from their own laptops or even phones. Once they purchase an insurance, they are just copy-pasting them in a specific folder that is a network share or over FTP, nothing more than that. They know exactly the naming convention of the file, and it's perfect. Well, things are changing a little bit, and the company wants to evolve a little bit. So they go to an IT service consultants company, it's also doing the implementation, and the company come up with a solution that includes blob storage for insurance information, or archiving storage that would move after a while all this content, Cosmos DB to be able to extract some information from the insurance and to put them inside the Cosmos DB, Azure Functions to be able to handle all the load and to serve the requirements, Web App to be able to host the front end, and also some caching for static content. Well, yeah, it's okay, it's fine. The solution looks pretty okay. Even so, what the company requires and what they are using now, they need just a simple solution to be able to store the files. Nobody requiring nothing more than that. They might extend them in the future, but their pain at this moment in time is the storage. They don't have enough storage, and it's very hard to maintain their file storage on their local machines. So you could start very simple. You could start only with Azure files, attach it to their network as they have now, and in time just add more functionality, more services, depending on their need. If their biggest pain is that in 1 month time, they will be out of space on their local storage and they don't want to extend the local storage solution, the first thing that you need to solve is the storage. And Azure Files, it's a great solution for that. After that, of course, You can add more functionality. You could put some front-end application and things like that. But this needs to become naturally in time, step by step. Now, let's talk about automation. Let's talk about infrastructure as a code. And I would like to ask yourself, do you reuse your templates? How often you are reusing your templates? And when I mean reusing your templates, I mean that you have an ARM template, you have some PowerShell scripts, and from project to project, or you're looking on some Git repository where Microsoft and also other vendors are providing templates, you are not starting from scratch. When you define an environment, but you are starting to reuse existing templates, maybe modify them, maybe changing them a bit, to be able to reuse as much as possible. Now, there are some pros and cons with these kind of things. If you decide to reuse templates and you just copy them from one project from another, and after that you are copying them again from another project to another, and so on, in time they will break. They will start to carry a baggage that is not used. You will ask yourself why we are having C, D, and E features in the template. Well, this is how we copied. So what is important here is to reuse the templates, but also at the same time, try to define a baseline. Try to define a baseline of templates that can be reused. This baseline can be from a public template repository, could be something that you design internally, could be from anywhere else, but you need to be very careful how you design this repository and to ensure that from time to time you are doing some refactoring, some cleaning, because it's important to clean it and to understand exactly what are the things that are usable, what are the things that are specific to a customer, specific to industries and to projects. To do some refactoring, because in time things are changing, you might understand better. Don't be afraid to use open source. The ones that are publicly available could be a very good starting point, especially nowadays when this area is more and more mature and you find very good ways how to design, how to reuse templates. And talking about generic, it's not easy and it's hard to find the right balance between how generic a solution you want to be. If it's too much generic, you cannot use it at the full capacity, and all the time you need to do some extra work. It is not too generic and it's too specific, you have the same problem, you have the same issue. And a possible solution to find a very good balance is the following. To have a template repository that is generic, and you have templates for specific services, maybe some orchestration between different services and things like that. On top of it, you add specific templates and orchestration of different templates specific to industry or business domain, like healthcare, like car manufacturer, like financial, for example, for payment gateways, because there might be some compliant requirements or some patterns that you see that are very, very common in most of the cases. So, for example, you could identify that for banks, for example, OpenShift or Pivotal are used. So it means that you would have specific for that industry templates that are well defined with Pivotal, that are respecting PCI DSS compliance and requirement and things like that. For healthcare, you might have something similar. On top of it, you design, and you might, if you have customers that have multiple teams, and you together with a customer you are running one or multiple programs, you might have specific for each customer templates that are specific for them, because you already know their security and cloud team internally from the customer, what their requirements and what their expectations. Additional to this, you might already know exactly that projects are using a specific set of services. So you already know exactly what you would use. And in this way, you can have a multi-level templates repository that starts from the generic layer, go more specific to industry and business domain, after that more specific to customer, and nothing more than that. Would be a good balance, but don't try to build this one from scratch from the first project. This should appear naturally. And there's one more thing here that is very sensible. Think about, especially if you are not part of the IT of the company that also use the service, you are just an IT service provider that is providing services to build, to implement, to design the solution. Who is the property of the templates? And this is very important, because many times people are forgetting that as the code that is written in Java or in C# or in Go and so on, also the templates, for example, the ARM templates that are built inside the project are the property of that customer. So you need to have and to agree with the customer that you can reuse it across their own projects or between customers. Because if you are using them cross projects, something that you develop on one project and you are trying to reuse on another project, also you need to take this into account when you're doing this, the estimation, and not charge customer twice for that. Another thing that is very sensible is open source templates. You might have customers that would say, well, yes, you can start from existing templates that are on the market. Nevertheless, you would have customers, yes, you can use open source template. Even so, I need to see this in your estimation. I want to see that if, for example, building from scratch, it would take you 10 man days to build the solution. If you're using some pre-existing templates from Git or from other open source repository, you would say that you would only need 8 man days. Now, we are ready for the closing, and my personal final thoughts are the following. We are living nowadays in a world that is changing very fast. The speed of technology is very high. It's crazy. It's almost impossible to be up to date with all the new trends, with all the new technology services, something like that. We need to be very careful to what kind of technology we decide to use, what is the right balance between over-engineering and use the right technology for our needs. And many times we don't give ourselves enough time to think. We don't give ourselves enough time to take into account and to put in balance pros and cons, benefits and effort, the risk of using different technologies. And because of this, it's very easily to end up with state-of-the-art products that look from the architectural point of view very nice, but they were over budget, they were not delivering time. There's a lot of business functionality that is missing because there was not enough time. Remember that the customer is looking to business value, nothing more than that. Think twice on how you match the customer needs to services, to microservices, serverless, to different storages, how much automation, how much complexity you are pushing in that side, because it's very easy to build an airplane when in reality you might need a car. And the biggest problem with this one is not that it's only over engineering, it's because one is flying or used to fly in the air before COVID, and the other one needs to go on the roads. And you cannot drive an airplane on a highway. You might land it in some situation, but nothing more than that. Thank you. Thank you for listening me. Thank you for Microsoft that's supporting this event. Thank you for Data Platform JIG and SQL Server JIG's communities initiative. And this is the perfect moment in time to talk, to share also your opinion, to ask me any kind of questions, and let's have a chat on different views that we might have on this topic. Thank you. Thank you for listening me. And if you want to contact me, you can do this directly on LinkedIn or on Twitter. Have a great day. Thank you.